So, welcome back is what it says there to start with. And uh, how was your time away from school? We've gotten to have a little of that discussion. But the rest of it is um, if we rewind to what was going on right before break, we only did kind of new stuff Monday and Tuesday of that week before break. And then Wednesday, Thursday, Friday, we really just mainly used as the opportunity to get caught up on things we were behind on, as well as there were a couple of Desmos activities that we put out there as extra credit opportunities. But the stuff that we're reviewing is clear back to Monday and Tuesday of that week. Uh, Coordinate plane, just plotting points and being able to label points, and then function notation and evaluating functions. And it's those last two things, the function notation and evaluating functions, that we did not really go over ourselves very much. There was a Ed puzzle. You see it listed here, number 3. Be sure you completed this Ed puzzle from Monday. Was about function notation and evaluating functions, and it actually provided like 8 practice problems, and the answers to those practice problems. So you want to make sure you've got that done. If you don't already have it done, just go back and do it. And then this Alex assignment from Tuesday, this Alex assignment gives you practice on all the coordinate plane stuff and the evaluating functions. And it's what would get us, make sure we're ready for this. This is unbelievable. Mr. Reed is trying to ask you guys to do an Alex quiz on the Monday after break. It's just rude of me, I admit, but it's trying to just see where we're at with the things that we tried to do Monday and Tuesday that we then just kind of left behind. And as I said, I'm going to review it all here. And the goal is to have it done before class tomorrow. But, if you need more time to make sure you're ready to roll with it, no big deal. Okay. Anybody have a question or thought that they would like to chill? I just read Malcolm's, hey, chill. Yeah, Giuliano, how could I? I don't know. Just because I'm a teacher and there's just this kind of meanness that runs through our veins. I don't know how that happens.
I mean, I don't have a problem with that. I like math. It's gonna be easy. So
Good. That was my goal. I'm not trying to give anything hard, just trying to give us the opportunity to demonstrate what we know. And it does give you the opportunity to go back and redo anything that you missed in the quiz. So hopefully you can just walk away from it with nothing but a beautiful 100% to make your grade all that much better. All right. Anything else besides, Mr. Reed, how in the world could you? All right, well, let's do some review here. Actually, real quick, if I go backwards to the beginning of our slide deck for the week, I can apply function notation and evaluate functions with one learning intention. And just reading through these success criteria, this first one says I can interchange y with function notation such as f of x. And all that's talking about is being familiar with and comfortable with the fact that if you see f of x or g of x, it doesn't matter what letter, h of x, whatever, that has the same meaning as y. It's just that the function notation gives us a couple of other convenient things to work with that just the letter y by itself doesn't. So they are very interchangeable. And anytime that you're like, oh my gosh, what's f of x? Well, just throw it away and put y in its place if that helps you think about it more clearly. Okay, I can find the output value of a function. For example, I can evaluate f of 3 given function f. We're going to go over that with a couple different problems multiple times here. So hopefully, if you're not already totally comfortable with that, we're going to get you there. And I can use the equation for a function to determine the output value or the range or y when given an input value or domain, which would be our x. The other part is I can graph points on the coordinate plane, identify the x and y axis and origin, identify the 4 quadrants, name the location of a point, the coordinate plane using ordered pair, and graph a point when given an ordered pair. So we're going to review all that stuff right about now, which means you're going to hear from me way longer than you might like to, but then we'll try and make sure that doesn't happen so much tomorrow. Just trying to make sure everybody's brain is back in the world of math instead of assuming that after a long 2-week break, anybody's brain would be there. All right, so quick review here, as quick as I can do it anyway. This is what we used before break to try and talk coordinate plane. We highlighted the x-axis in yellow. We highlighted the y-axis in green. And then as we talked about, well, how do I identify the ordered pairs that go with a point? One way is to start at the origin and count. I can figure out the x coordinate by starting at the origin and starting to count 1 after I leave the origin, and 2, count till I'm even with something, even with the point I'm trying to label, and then do the same thing with the y-axis. Don't start counting 1 until you leave the x-axis, and then 2, 3, 4, 5, 6, 7. So that's one way, and I think the way lots of us would have learned it. But the other way is just going to the point and following it down to the x-axis to figure out, well, what x value is it even with? And that's your first number. What y value is it even with? That's your second number. So whether you like that counting method or just trying to look at the axes and figure out what the points even each axis, either way is just fine. Any questions here, guys? I'm going to go kind of fast with these first couple ones that are about the coordinate plane, but please stop me and ask all the questions that you would like if you could use some assistance with any of it. So this first problem is just about identifying the ordered pair that goes with certain points. And up here in the right corner of each of these examples, I've put how many of these problems were on the assignment from December 15th, as well as how many of these problems are on the quiz that I assigned today. So there's 3 just like this on that assignment and only 2 of them on the quiz. And it says, give the location of Paris as an ordered pair. Well, just like we were looking on the previous screen, we can figure out what number is it even with on the x-axis. And right there, I see that it's even with -5. And then what number is it even with on the y-axis? I see that it's even with number 4. So the x coordinate was a -5. And I'm not in ALEKS. This is just a screenshot from ALEKS. So of course we'd be typing that in ALEKS. And then the y coordinate was that +4. So we would have typed into those boxes a -5 and then a +4. Any questions there?
No, sir. I know you missed my voice cracks.
And you know it. All right. So then we're just going the other way around. We're given an ordered pair and asked to plot it. We're using this pencil tool, which again, this is just a screenshot, so I can't use it right now. But the wonderful thing about it is once you click on that pencil tool and you come down here, you'll have a line going up and down and a line going left and right. So it makes it really easy to make sure you're even with -4 on the x-axis, that would be right here, and then even with -6 on the y-axis. So it would be right about there that you would click to plot that point. Moving right along. Well, I didn't ask for any questions. Were there any up there? All right, so 3 problems on the assignment, 2 of those on the quiz. And then this is where we're dealing with quadrants. And this is from clicking the little icon that's over to the right that looks like eyeglasses. It gives you an explanation when you're working on an assignment, not when you're in a quiz, but when you're working on an assignment. And so this explanation came right out of clicking that when I was working on this problem. But it's just a nice summary of quadrant 1, 2, 3, 4. That's how we number the quadrants. Start in the top right one and go around counterclockwise. And then the y-axis is the red one, the x-axis is the green one. So that's also, I didn't show you, but that is also in our slide deck. Not the same thing, but same ideas. Here's how you number the quadrant. There's a little bit about points and ordered pairs. I'm going to go ahead and number the quadrants here. So I think, yep, just like they're showing me over here. So the top right one is quadrant 1. And then I go around counterclockwise. So this is 2, 3, and why the Roman numerals, I don't know. Every once in a while, you'll see them labeled with regular numbers, but usually you'll see that it's done in Roman numerals like that. So I need to identify the quadrant or axis that each point's on. If a point's on an axis, it's not in a quadrant, so you just identify the axis. We would click on this this menu, drop-down menu. I knew there was a word for that. This drop-down menu and find where it says y-axis. So this one's going to say y-axis. And then point J, since I went ahead and labeled them, that makes it kind of easy. This bottom right one is quadrant 4. And then point P, the top left one, is quadrant 2. And point Z is in quadrant 3. Wow, we're getting mega sloppy here, but that's supposed to say quadrant 3. Any questions? I put three of these on there because I feel like it's what we have the least practice with, and so I just wanted to give you as much opportunity to sink it in your brain about quadrants. All right, then there's just 2 more, and they are about evaluating functions. So here we go. We're going to go back to our best friend Desmos that we have been trying to make use of. It's a great calculator, along with it does a lot of other things. So let's just read this, and then we'll eventually employ Desmos. The function h is defined by the following rule. It shows us this h of x equals 3x minus 4, or 3 times x minus 4. This h of x, remember, it's interchangeable with y. So you see over here, I've already replaced it with a y. Just as a reminder, they really do have the same meaning. And this x and h of x table is really just an xy table, something that I think most of you have seen plenty of, where you just plug in the x value, calculate the answer to find out the value of y. So just constantly remind yourself, the function notation, if I hate it that much, I can put a y in its place to make it all a little easier to work with. So I'm going to go ahead and write the function notation here. H of x in place of that y equals 3x minus 4. And this is just my h of x value, which is the same thing as saying my y value. The numbers in the table are -4, -1, 1, 2, and 3. Those are just the x values they want us to evaluate this function for. So if I keep using my function notation, when I'm trying to find a y value when x is 4, the easy way to say that with function notation is h of -4 equals, this means I'm replacing every single x with a -4. So I use parentheses when I replace my variable, and this means 3 times -4 take away 4. Well, that would be a -12 take away 4, which would give me a -16. All right, so the value of function h when x was -4 turned out to be -16. This is where we would be typing in -16 into the box there. I'm kind of pausing in case we got anybody with a question about the craziness we just did. In the meantime, I'm going to try this. I'm going to put this over to the side a little bit. Hey, how do I do that? That's not where I'm supposed to be. Hey, oh yeah, there's where I'm supposed to be. So I'm going to keep evaluating this, but first I'm going to find our best friend Desmos. www.desmos is one easy way to get there, but that's 3 W's, Mr. E, DESMOS.com. You can log into Desmos if you'd like, but right now it doesn't really matter. We're just going to use it as our calculator. So what I'm about to do is just type in what had to be calculated. The 3 parentheses negative 4 take away 4. So 3 parentheses negative 4 take away 4. And you see right away it gives me the answer. If I back that up, 3 times negative 4 really was negative 12, but I want the final answer of negative 16. Okay, the wonderful thing about Desmos is now that I've done that, I can really just plug every one of these numbers in there and get my answers and be done with it. I'm going to continue showing my function notation. I now want to apply function h to the x value of negative 1 to find out what's the value of function h when x is negative 1. So I just plug it in. But this time, I'll just come right up here to Desmos, and I'm replacing that negative 4 with a negative 1. And right away, it's telling me I have a negative 7. Then I need to do 1. So one more time, I'm going to write my function notation, but for the sake of time, I'm not going to do every one of these right now. So 3 times 1 take away 4 is going to leave me with a negative 1. But again, I can very easily find that out. Instead of negative 1, it's supposed to be positive 1, and there it agrees with me. That's a negative 1. Okay, so I can just keep right on rolling with that and get it done relatively quickly if I'm using Desmos in the process. So I wasn't continuing to write my answers where we would have to type them, which would be right over there. Does anybody have a question about that? Because there are 5 values to plug in, that's why the assignment only had one of these and the quiz will only have one of these. The crummy thing about it is if you get just one of them wrong, it's going to tell you you have part of the problem wrong, but it won't tell you which value is wrong. So again, that's why Desmos is helpful, and Mr. Blake and I are certainly willing to help with that kind of thing as well. Here's the last one. This is a good example that's showing why being able to call one of the functions f and another function g makes it really much easier to talk about these two different equations. Yes, this could be y, and so could this, but then I'd have to talk about that equation on the left and that equation on the right. But now I can just say, oh, function f, or I can just say function g. So I just have to find a value of function f when x is 2, and separately, I need to find the value of function g when x is negative 3. So let's do f of 2. Whoops, maybe I should first of all write down what the function is. Function f with respect to x is negative 4x minus 3. So now when I go to do f of 2, it's much easier for me just to go ahead and plug that in, where I see that x is going to become a 2. And there we have it. Again, my best friend Desmos can figure that out for me very quickly. Negative 4 times 2 minus 3. I could completely delete this equation by clicking on the x, or I can just come down below it and plug it in there. So negative 4 times, no, that doesn't seem right. Yeah, it is. Negative 4 times 2, no. Take away 3. And there you have it, an answer of negative 11. All right, so f of 2 ends up being negative 11, typed right into that box there. Then separate question is about function g. So I'm going to write function g down. It is 2 times x to the second power minus 3 times x. They want me to find g of negative 3, which means I put in negative 3. When you have a negative number replaced in a variable, it's really important to put parentheses around it, because it's the negative signs that will often throw us off, and they get really complicated if you don't put them in parentheses. So I now just have to evaluate this. But there is a reason I have a good friend, Desmos, because my brain doesn't really want to deal with all those negative signs, but Desmos doesn't mind. So again, this function notation is just asking me to find the value of the function. It's this over here on the right side of the equal sign that I actually have to calculate. So I type in there 2 parentheses negative 3 parentheses. Now, in Desmos, you can't see it, or I can't see it on my Chromebook, so I'm guessing a lot of you can't either, but meaning within Zoom, the way I'm sharing my screen, you can't see it. But in Desmos, in the lower left corner here, there is a nice little keyboard. You can click on it, and your exponent button right there, a squared, would put the exponent 2 on there. The other option is to press Shift 6, that little upside down V above the 6 we call a caret, and that's another way to do an exponent. And then we need -3 times -2. The wonderful thing about Desmos is I can type it just like it looks and trust that I'm going to get a good answer. That 24. Nobody said, hey, Mr. Reed, we were supposed to be replacing all the x's with -3. It's a good thing I had done this several times today and already knew the answer, because 24 is not the answer I've gotten all day. Let me fix this. Sorry about that, guys. But there's nothing better than a teacher making a mistake so that you know that even people that have lots of experience with this stuff can make mistakes. And all that mistakes do, as long as we choose to learn from them, is help us learn more and get closer to success. All right, so that should have been a -3. Now, if I go back to Desmos and fix that, by golly, it tells me a correct answer of 27. So Desmos is only as good as I choose to make it. The answer there was a +27. That's what I'd type in, and voila, I'd be all done. Any questions, guys?